Div 2 problem B. We have an infinite plane with Cartesian coordinates. There are several cities, several integer points, which are chosen as major cities. What means that they're majors? This means that you can travel between two major cities for zero cost. And between any two other cities, you can travel at Manhattan distance cost. Manhattan distance is the sum of modules of differences of, not of modules, I think it's called absolute values. The sum of absolute values of differences between x's and between y's. You need to find the minimum total cost for traveling between one point and the other point. Actually, there are two cases which are both need to be considered. So if we have 2 points, we actually either use major cities or we do not use them at all. If we do not use them, we just go from one city to the other via Manhattan distance. So the answer is xa minus xb, this is a, this is b, xa minus xb plus ya minus yb. The second case is that we use one or several major cities. Actually, this means that we can just consider only the first and the last major cities that we used. Why? For example, let it be the first major city that we used, and this be the last major city that we used. Between these two moments, we can assume that the cost is zero, because if the cost was non-zero, we can optimize our route and replace everything that happened between these two cities with just one direct travel from here to here. And this is of course zero, so this is indeed an optimization of the route. So xa minus, let it be, for example, a, and let it be b. And in this case, we get this. And the same goes for b's. Sorry, I will move it a bit to the down, to the bottom, because I interfered my image. So as you can see here, there is a choice of A and B. Which cities we need to choose? Actually, we can choose the nearest. So because you have actually two independent parts. You need to get from A to any green point, and you need to get from any green point to B. Then you can just iterate over all green points and choose the nearest one to A and nearest one to B. And this will give you the answer. Let's solve this problem in programming language, C++. In my solution, there will be two distinct parts when we read the input data and when we process the input data. Actually, read input data and print the answer. This is the one part, and the other part is totally dedicated to computing the answer. Also, what you really need to look at is constraints. So as you can see here, constraints are between minus 10 to the 9th and 10 to the 9th. This means, let me write it. So x and y are between minus 10 to the 9th and 10 to the 9th. This means that the maximum possible value of this number is something like 4 times 10 to the 9th. And this is actually quite a big number. This is near the maximum number of uint 32. And this is kind of a problem, because if you just try to do the same thing here, you will definitely get overflow, because this can be 4 times 10 to the 9th, and this can also be 4 times 10 to the 9th. So the easiest way to deal with it is just use long longs. So int 64. And we will do it. So we read n, k, a, and b. Actually, all cities which are not major, they simply don't matter at all. So n, k, a, and b. Then we take a vector pair int v of size n. Also, actually, we will decrement a and b because we want to have 0 indexed indices. And in the end, we ask for find ans of VKAB. And find ans will be the function which takes a vector of coordinates and a number of major cities and numbers of two cities between which we travel. We need a subroutine which calculates a Manhattan distance between 2 points. This subroutine simply takes ups, actually long of apps of a dot first minus b dot first, and plus long of ups of a dot second minus b dot second. When we have this subroutine, the rest of the problem is quite easy. First of all, we take long from a to b, which is simply distance between VA and VB. The second thing we need to do is, we need to create variables for getting from A to major city. And we initialize it with something very big, which is totally greater than any possible answer. For example, 5 in 9 is definitely bigger than an answer. And And also we take from major to B. It is also 5 in 9. Then we iterate over all major cities, which are K and not N. And we say that from A to major is minimum of from A to major, and actually distance between VA and VI. And the same thing we need to do with the second variable. It is minimum of its, this operation is called relaxation. And the new value is minimum of the old value and the distance between VI and VB. When we have done all of this, we say that we again relax the answer. We say that from A to B is minimum of from A to B, and the sum of these two halves. And we actually just return this number. Let's check the outputs. It should be 4 billion 022 1. 4 billion 022 1. It is correct, so we can just submit it. And we get accepted really fast.